Hello. In this segment, we're going to be talking about data formats. How do we represent characters, pictures, sounds, and videos in the internal representation of a binary computer? In a computer, everything is binary. Computers operate on switches internally. These are either on or off, which makes the base 2 number system its natural base. So characters, images, and sounds, how can they be represented in binary? Let's look at characters, for example. There are two main mappings for characters in the computer systems. There's ASCII, the American Standard Code for Information Interchange, and Unicode, the expansion of the ASCII character set for many different kinds of character sets. And these map the binary numbers into printable characters. So, for example, if we look at the character W, what the CPU sees is this binary digit. But what we see interpreted on the screen is the character W. So the implication here is that conversion of numbers to be printed to numbers needs to be converted to strings in order to be printed. So for example, the string 1234 and the number 1234 have very different representations. For example, the top line is the string 1234, whereas the bottom line is the number 1234. And as you can see, those representations are very different. If we want to print out a number as a string on the screen, we would need to convert from one to the other. Pictures then. Pictures are represented by components of colors: red, green, blue, and alpha. Alpha is the transparency layer. Each of these are represented by 8-bit quantities, and so what we get is a 32-bit number. The 32-bit number represents a color by mixing red, green, blue, and alpha. So for example, the yellow color in the banana is FBC527FF as the red, green, blue, and alpha components. We can do the same for the color in the orange and the red color in the strawberry. A picture then is just a matrix, rows and columns, of these numbers that represent the colors. In practice, an 8-megapixel image, which is a very high-definition image, would take about 32 megabytes of space in an uncompressed format. But advanced compression techniques such as JPEG reduce this to about 2 megabytes. Sound. Sound is a wave that travels through a medium. It's some energy form. And so, how do we represent a wave of energy in a computer system? And the answer is that we sample the amplitude of that wave many times per second, and we record that amplitude as a number. So here's an example of a sound wave. The lines on the bottom represent the times at which we sample the amplitude. And so we play back this sequence of amplitudes, and we get an approximation of the original sound wave. CD quality sound is about 10 megabytes per minute in its raw format, because it uses a 16-bit sample over 2 channels at 4,400 hertz, or 44,000 hertz. But we can reduce that by a factor of 11 by using a compression technique, MPEG, that eliminates some of the sounds that the human ear can't hear. Video, then, is a series of pictures, and we've already seen how to encode pictures, and the sounds that go along with those pictures, which we've also already seen. If we look then at a series of pictures as a flip book, if we play each individual frame back in this image, what we would see is an image of a horse that is running. But it turns out that there's not much difference between this picture and the previous picture, or even the next picture after it. So why encode everything in that picture? What we can do is instead just encode the differences between the pictures. And so the advanced compression technique of MPEG encodes only the differences between frames. MPEG has 3 different frame types: I-frames, P-frames, and B-frames. I-frames are encoded using the standard JPEG picture compression, and so these are just individual pictures, fully encoded. P-frames then encode the differences between either a previous I-frame or a P-frame. And then B-frames are bidirectional frames. They can encode differences from either the previous or the next frame, regardless of what type it is. So this can move forward or backward. In summary, computer systems only manipulate binary numbers. All data representations inside computer systems, that is, characters, images, sounds, and videos, are ways of encoding and decoding binary information for human use. We have standard encodings for ASCII and Unicode for characters, RGBA colors as a matrix for pictures, samples of amplitudes for sounds, and flipbook pictures with differences between keyframes for videos.